have the positive version and the negative version of this.
It took me forever to remember this.
Yes.
What I did.
So we always have a positive and a negative. So we have a positive version of x minus 7 equals 16, and we have a negative version of x minus 7 equals 16. So this one, we typically just see that we just move the negative to the other side. The positive doesn't change anything. So we have two separate equations that we're solving, which means we're going to have two separate solutions. Okay? So go ahead and set your bell ringer aside. I will pick those up. I had our quote for the day on my email. So if you want to write your quote in your interactive notebook early, it's always the tagline on my email that I send out on Mondays as the reminder for it. So today we're looking at Acts 17:28. It says, "For in him we live and move and have our being." This is one of my favorite verses. And our lesson today is all about movement. Movement of graphs all over the place, all the ways that we move. So I felt this was an appropriate quote to go with our movement for today.
Sure got my hoodie today.
I know, it's cold. It is cold in here. I've had a hoodie on a little bit beforehand. Okay, so we're going to be finishing up chapter 2 today. We paused last week because we needed a little bit more practice on what we were learning with piecewise functions and our inequalities. And I felt like that was a good pause. Sometimes it's okay to just say, hey, I need a little bit more time. How did you guys feel about the homework and the piecewise and everything this week?
Yeah, I'd say it was pretty good.
Okay, so you feel comfortable that we've taken our, initially we've learned our whole lines. Now we've chopped them up into pieces. We've been able to give some boundaries to those functions. Yeah. We've combined more of those functions together. So again, we're just building. We're taking these little steps as we're moving along. We started with a whole line. Now we've got parts of a line. Now we're adding lines together. Now we're going to start moving everything all over the place. So we're going to finish up with section 8 today, going over our absolute value inequalities. And we're going to do inequalities. I'm going to show you a little bit of what that will look like. And then we're going to do a big section and lots of practice today on movement. In him we live and move and have our being, And so we're going to move them all over the place. And so what you're going to be able to answer by the end of the day is you're going to be able to graph an absolute value function. So we're going to start with the parent function. We're going to stretch and compress it. We've had these words before. And so we're going to review them again, knowing that it's A. A we talk about as slope. We're going to be able to predict how the function moves according to H and K transformation. So we're going to have some new vocabulary that's going to come in to this. Again, we're going to have the visual of what does it look like, and then we're going to be able to name the domain and the range for the absolute value function. So these are our 4 wins for the day at the end of the day that we're going to be able to get to. Okay, so the first thing, I'm going the wrong direction on there. Okay. So new vocabulary for today. Let's think about what we have. So I've talked a lot about the main point here in Algebra 2 is to have a face for the numbers on the page, right? We've been talking about what does it look like? Everybody in life likes to put a picture with something. A name means nothing unless you have the face of them. You can see a list of names and you're like, okay. It doesn't elicit a response unless, for you guys, it might have your sibling's name or it might have your best friend's name, and then you're like, oh, I know that name. I can see their face. Statistics show that we buy cookbooks that have pictures with our recipes in significantly greater quantities than we buy cookbooks that don't have our picture a picture of what it's supposed to look like with it. And so as we move through, we want to see what these numbers look like. And so today, that's what we're going to be looking at, all the ways that the numbers make something move so that we can see it, okay? So, do you guys think that every single function has a definite picture?
No. Well, every single function.
That
I guess,
it?
Yeah. Probably. Yeah.
Okay. So as we move through, we're going to be able to look at it, and that is going to have its own specific picture compared to something different. Okay. And then what are the different ways, if we were looking at a coordinate plane, what are some different ways that a function can move? So we have a coordinate plane. I have a function. A function is simply just a graph, right? A graph that has one requirement. What was the requirement for a function?
It can't have it can't if you put a vertical line through it, it can't have two or hit 2 points.
Excellent. Perfect. So this is a graph, but it's not a function. Okay, so right now we're narrowing down our definition of our graphs to those that are just functions. Okay? So what are all the ways that a function can move? So if I have a parabolic function, what are some ways that it can move on this graph?
It could reflection.
Reflection. So it could reflect over the x-axis, and it would look like that. Correct? What is another way that it can move?
Dilation.
Yeah, we're gonna look over those in a minute. Right now, we're just talking about if I had this, how can I move it around? Can it go up or down?
Yeah.
We can move it up. We can move it down.
Side to side.
Side to side. Okay. Can we do both
Diagonally up.
up and to the side?
I mean, you can put it basically anywhere.
Yeah, we can put it anywhere. It can go anywhere on the graph. We talked a little bit last week that it can get skinnier. It could get wider. I love that you said it could flip upside down. So there's lots of different movement in our vocabulary for that. If you will write this down in your notebook, is reflection means to flip a function over. Now we can reflect two different ways with a coordinate plane. We can reflect and flip it over our x-axis, right? Yeah. We can also reflect, so we have a function like this, and flip it over our y-axis. It can go back and forth that way. Okay, so two different points of reflection. Just means it's like a mirror. If we were to stand a mirror up right along there, how is it going to, change it? Right? Our next one is dilation. This is an interesting word. You've heard me talk about getting skinnier or wider. Okay, we also added these two words in our vocabulary last week that it stretches it. So our definition of skinnier means it's being pulled up and stretched, so it got skinnier. Our definition of compress, if you're to get squished and you're like this, you're pushing it down and it's getting wider. The main term for that is called dilation. So if you are on a standardized test, ACT, and they talk about dilation, we need to add this vocabulary to our stretching of skinny and wide. Okay, so we're growing our vocabulary. Rotation is going to turn a function sideways. We are not going to address rotation right now. We will address it later on. But rotation is what happens, is we see that a lot when we've got inverses and things. I might take it and I'm going to turn it to look like that. So where rotation is a turning sideways of it. Okay. And then translation is all of the slides and shifts. So it's all the movement around. It hasn't changed its form. We're just moving it all around is our translation vocabulary word. So when you see those, we know what our new vocabulary is, okay? Some other new vocabulary that we've got is axis of symmetry. The axis of symmetry is the line that identically reflects the graph. So in geometry, you learn that an axis of symmetry is the part that cuts it right down the middle, and it's the same on the left and the right. It's exactly the same. That's what this means.
Okay.
It is the line that cuts your graph right down the center. The thing that's important to read about this is that it is a line. Is a line ever written as a number? If I identify a line, we've been learning about lines. So in the lesson 1, 2, and 3, we talked about all the different equations of lines in slope-intercept, point-slope, standard form. Wherever any of those, just a number. Can we have an equation of a line that's just a number? Or does it have to have an equal sign?
I
Okay.
think it. If it's just a number, wouldn't it be the x-axis?
It could be y.
So yeah, you do have to have it equal.
Okay, because we have to define what that goes to, right? So a line is always an equation. There should always be an equal sign there. So that means when you are asked for your axis of symmetry, it will never just be a number. It will always be a y equals or an x equals. It must be written as a line because it is an entire line for that. The other vocabulary that we have is vertex. In geometry, we talked about vertexes being the end points, maybe on the outsides of a rhombus or a trapezoid.
Yeah.
For that, in this, our vertex is always found on the axis of symmetry, and it is the point at which the graph changes direction. Okay? So, which makes sense in geometry if you are looking at a parallelogram on a coordinate plane, and they call these vertexes, because if I am tracing around, I get to this point and I change directions. And I get to my other point and I change directions. And so these are the points at which it changes directions. What we are going to be looking at is for an absolute value function, our vertex is the point at which it changes direction. If we are looking at a parabolic equation, our vertex is that point where it changes direction. We're going from a negative slope to a positive slope. If we have cubic equations, we might have two vertexes because that's where it changes direction, okay? So any point where our graph changes direction is going to be called a vertex. For our information today, we are specifically going to be looking at the vertex that is always on the axis of symmetry, okay? So we're gonna explore an activity on Desmos. I'm gonna pull that up on here. Okay, and we're gonna see where our absolute value comes from and how we can use the vocabulary that we just learned. So initially we have a line, right? What would be the equation of this line?
It'd be y equals x.
Perfect. Y equals x. This is
The
our
function.
parent function. Phenomenal way to use our vocabulary. This is our parent function. 45-degree angle, y equals x when x is 2, y is 2. We're straight through all of our connection points on our coordinate plane. Okay? So we have y equals x. Now, if I add a part, and I now have, what is this one?
X equals
Negative.
y?
Oh.
Wait, no.
Y equals negative x, because it's negative slope, positive slope. So the only thing that changed was the slope. So this is actually -1, right? And that's +1. Right? So this is y equals negative x here. What vocabulary word did we just see happen? And look at your list.
Absolute. Well, no. It'd be a
Just be a
Reflection?
Reflection, perfect. Reflection across the y-axis. We have reflected across the y-axis. Okay? So now let's look at this one. Okay. What is this guy still?
Reflection.
Well,
It's still y equals negative x. We just did what? From
we reflected off the x-axis.
we reflected across the x-axis, and if we were looking at this in a piecewise function, this is just addressing which values of x?
Positive and negative.
Okay, positive values. Does it have any negative values of x?
Oh, no.
So it's the positive values of x and the negative values
Of y.
of y. Okay, so our domain is all positive x's.
Mhm.
Our range is
All negative.
all negative y's.
Okay.
Excellent. Okay, but this is a reflection over the x-axis. Right? So two different terms we've got. Now, do these together make a function?
No.
No, they do not make a function. It is two separate graphs that must be graphed, in a piecewise section. But we cannot say that it's a function because it does not pass that vertical line test. Okay? So if we combine our first two that are functions, we end up with our absolute value function. Let's see, we called this y equals x, we called this one y equals negative x. Does it make sense that this is our absolute value function?
Yeah.
Because absolute value means I have a positive version and a negative version of my x. I have a positive version and a negative version of my x, okay?
Yep.
So here's our absolute value function. It looks like a v all the time. Okay? Our axis of symmetry is this green line that just showed up right down the middle, and it has an equation. What would be the equation of this line from our lesson at the beginning of the chapter? How would I write the equation of my green line?
Like just to.
Y equals 0.
Okay, so y equals 0 means that no matter what value I pick for x, my y is 0. So if I pick 4, so y equals 0 is this line,
So x equals 0 would be.
x equals 0. No matter what value I pick for y, my x equals 0. Okay? So my axis of symmetry, if I'm answering my question, my axis of symmetry, I'm going to say x equals 0 for that. Now, my vertex is the point at which it changes direction. Where would my vertex be located?
0, 0.
0, 0. At this point, our vertex is at 0, 0, and that is called the origin.
Okay.
Now, as we had explored before, we could change it and say y equals negative x. Okay, and what has happened now with our vocabulary? What?
Or reflection.
A reflection how?
On the x-axis.
A reflection across the x-axis. Perfect. What is my axis of symmetry for my reflection?
Well,
X and.
y equals negative x.
And my axis of symmetry, just for my reflection graph.
I mean, both of them though, right?
Did it change?
No.
Did my axis of symmetry change?
Well, I guess no.
No, it didn't.
So it's still.
When we reflect it directly over our our x-axis, our axis of symmetry will not change. We still have the same axis of symmetry. In this case, because our vertex was at the origin, did our vertex change?
No.
No.
No, our vertex didn't change either. So we have the same thing on that. So as we move into our next little hands-on, we are going Okay. So what I want you to do is I want you to get out your coordinate plane whiteboard, and the new clear sheet that I just gave you. So much for it being on silent, right? Okay, so what we're going to do is I want you to set your clear sheet on top of your coordinate plane. The one, yeah. Just right on top of it, yeah. And so we can write on it. And so just over on the top part of it, and I want you to draw the parent function of the absolute value equation. So we just talked about our parent function is going to have a slope of 1. It's going to go directly through.
Wait, so draw on the clear sheet?
Yeah, draw it on your clear sheet. So just draw a parent function. So it should look like this. Draw both sides of it as it goes up. All right. Well done. Now we're going to get to use this, and we can move it around. So now we're going to visually get to be able to see it. So now let's look at y equals negative x. So now we have that negative. We have the inverse. So how would you change your graph to be negative x? What do you think? How would we move our graph? Now we have this value in front of our absolute value. So we're leaving our absolute value function the same, but we're changing the slope from a positive to a negative. How would our graph move? So move your graph on your plane.
Reflection.
Okay, so what would that look like?
Would you?
Okay. Yeah. I just flip it. Or you can just, to kind of see, we're just going to take it and flip it directly over like that, right?
Yeah.
Okay, so now that's down. So yours should look like this, correct? Okay. What I want you to do is flip it back over and start with your absolute value function above the origin, the vertex above the origin. So move it up to 1. Move your vertex up to 0, 1. Okay, and now flip it over. Where should it land?
The 1 on the other side.
Okay, so now we're at 0, negative 1. Okay, so if we're at the origin and we flip it, what happens to the vertex? If it starts at the origin.
Changes. Well, it goes to the negative version if you flip it.
If it's not at the origin,
Right.
correct, our vertex will move.
Mm-hmm.
Okay, if it starts at the origin, does it move?
No.
No, it just stays at the origin. Okay, so your graph should look like this when we flipped it over and it was right there at the origin. Okay, we already talked about it flipped over. Okay, so let's erase your graph. Okay, just here I've got all of your things. Is that one?
Thank you.
You're welcome. Okay, and start initially with 4x. Remember, as we're doing absolute values, we're going to start with our original one without the absolute value bars, and then we reflect it. So 4x looks like what with a line? A slope of 4. Okay, so graph your slope of 4. Slope means rise over run. So we should be going up 4 over 1, up 4 over 1. Okay, now to find the absolute value, we need to reflect it across the y-axis. So we're going to have our matching guy on the other side. Okay, so does your graph look like this now?
Yep.
Okay, so what changed about the graph?
It got narrower.
It got narrower, and what was that called with our vocabulary?
Dilation.
Dilation, and what type of dilation specifically?
Compressed.
Stretch.
Oh, it's stretch.
It's
Yeah.
so if
It
we're
got
here, we got
longer.
pulled up. It's
Yeah.
stretched. Okay, so vertical stretch. Okay. Did any other part of the graph move?
No.
Did the axis of symmetry change?
No.
Did the vertex change?
No.
No, we just stretched it and
Yeah.
pulled it up. Okay. So now let's do this one. 1/2 x. So graph that one. How would that look? So we're starting with our linear function of y equals x, but we're making the slope 1/2. Rise over run. Excellent, that looks fantastic. Good job. Well done. Okay. So does your graph look like this now? Okay, so what changed on this one?
Compressed.
We compressed it. Okay, did the axis of symmetry change? Okay, what is the axis of symmetry?
X axis. Or
This
y
is the
equals
x-axis.
Should be the y axis.
The y-axis, what's the equation of the y-axis?
Y equals 0 or 1.
The y-axis is telling us for every value of y, our x value is 0. So our y-axis is x equals 0. So you have to think of, we can't label our y with a y equals. Our x-axis is our y equals 0.
Okay.
Think for every value of x, y equals 0. For every value of y, x equals 0. Okay? So our axis of symmetry is still x equals 0. Our vertex is still located where?
0.
0, 0, which is called
The origin.
the origin. Fantastic. Okay, so now let's explore this. Okay. If I had the linear equation y equals x plus 3, my slope is what?
Just
1. So I have my parent function, and this tells me that my y-intercept is 3, which meant that my line did what?
It starts at 3.
The
My
vertex
line would
changed.
start at 3, and I would have my parent function that way. Okay? So remember, for absolute value, we draw our line. We use a piecewise to bound it just to the positives. Okay? So let's draw, we're going to go back to draw our parent function, y equals x. Absolute value of x there.
Wait, so just draw the parent function?
So draw our parent function first. We're going to start here.
Um,
So just a quick, doesn't have to be perfect, we're just exploring how these move. Okay, and if it was a regular line, if you were only looking at half of it, right? So if you were not looking at this left side and you're only looking at that part, and this was a regular linear equation, and I said x plus 3, y equals x plus 3, that meant my line has to cross at
3.
3. So let's move our graph to where our line crosses at 3. Okay, what did you do to your graph?
Move the vertex.
Yeah.
So a translation.
We did a translation. We moved the vertex up. our graph shifted from 0, 0 up to 3. Did anything else change about the graph? The slope didn't change, so dilation didn't change. Did it move along the x-axis at all?
Nope.
Okay, it only moved along the y-axis. So we see that when we add a number on the outside of x, just like when we added a number on the outside of our linear equation, we can answer that question when x equals 0, which completely erases it, y equals 3. So we've got shift vertically. Right? So let's look at this one. And we're going to start with our original one. So again, just move it back down to the origin. And I want you to move it to where it matches the graph that I have up there. And I want you to do it in 2 separate steps. So don't go diagonally, go left and then right down, or go down and then over. And how can you get your graph to match what's up there? Okay. So what was one movement that we had to make?
We'll go down the y-axis.
Yes.
We had to go down by how much?
5.
We had to go down by 5. So we went down by 5. Okay. Right, to get here. So
Yeah.
there's my 4. Okay. And then we had to do what?
Go to the left 4.
Okay. So this was down. We're going to label that -5. We went left, -4. All right. And we moved our vertex. Did we change our slope? Was it compressed or
No.
stretched? No, we just moved it around. Okay. Do we see these numbers anywhere in our equation?
Yes.
Okay. Where do we see -5?
Outside of. That's our. Well, I guess we could consider our intercept.
Yes, it is outside, not attached to x. So in the same way, when our x equals 0, when we're erasing all of that, it's on the outside, so it's on the opposite side of the equal sign from y, so we have a y equals -5 option here, right? And that was our shift down. So then let's look, do we see -4 anywhere?
Yes.
Well,
It would be the negative version of the absolute value.
yeah.
So could we rewrite this as x minus -4?
Yes.
Is that the same as x plus 4?
Yep.
Minus the negative? Yeah, I just rewrote it. Looks a little different.
Yeah.
Minus -4. So we have our 4 here, but we have the opposite sign
Yeah.
of what's on the inside. Let's think about that, because to have an equal, if I have x plus 4, these are on the same side of the equal sign, correct? Same side?
Mhm.
So to get an x equals something, I need to move this guy over. When I move him over, we change sides, so we change signs. Because they start on the same side of the equal sign, we have to have the opposite value when we're actually solving for it.
Yeah.
Right? So there's our solution thing. So we do see it as we move through there. Now, these guys have some new vocabulary that we're going to add. Okay? So A, we've learned that in AX plus BY equals C. So there's our standard form of our linear equation. We've seen A before. We often call A M. It can also be called K, right? The constant of variation. So that same number has several different terms for it. But it is the coefficient of the beginning of your x stuff. It's the slope, and it affects your dilation. Right? Because it's our slope. So it's telling us if we've stretched it or if we've compressed it. it's that first portion from the vertex to your very next point. It tells you the slope of that value. Okay? H and K are new values. They will often be written as a coordinate pair. They pair exactly with X and Y. It's so nice, it's alphabetical. X, Y, Z, H, K, J. So if you're ever wondering which one goes with it, well, alphabetically, X comes before Y, H comes before K. Okay? Since they pair alphabetically like that, they also pair in our equations like that. So anytime you have an H, it will affect the X. Anytime you have a K, it will affect the Y. So they are pairs that go together, okay? H is always paired with X, and it moves the function along our X-axis.
Okay.
So it means we're going left and right along our X-axis. However, it's always an inverse connection. We just looked at that because we have to move the value to the other side of the equal sign. So if I have X plus 4, am I going to go to the positive side of my coordinate plane? Or am I going to go to the negative side?
You're gonna get positive.
X plus 4. It's an inverse connection. So if this says positive, it means I'm going to move it negative. That means I'm actually going to move it negative 4. If I have X minus 7, I'm going to move it
Positive.
to the right side, positive 7,
Okay.
along the axis. Okay? Now Y is always paired, or K is always paired with Y. It moves the function along the Y axis, up and down. It's already on the opposite side of the equal sign as Y. So it is a direct connection. If it says positive 5, I'm going to go
Positive.
up 5. If it has negative 4, I'm going to move my graph down 4. Okay? So these are our instructions as we move through. Okay? So now that we have all these extra values, we get to have our standard form for moving any absolute value equation. Okay? Y equals A, so on the outside, X minus H, we end our absolute value plus K. So this is an important equation to know and have written down. So A value is our slope, H value is our X-axis shift, and K is our Y-axis shift. Okay? So here's our 6 rules that apply to our standard form. Rule number 1, A is our slope. Always starting from your point of your vertex, moving to the right, that very first point. Okay? HK is now our vertex. So we have information inside already because this is the point at which it changes direction. So HK is our vertex. So it's kind of like standard form and vertex form of a linear equation combined into one equation. Okay? H is always the opposite of what you think it is, right? It's that inverse relationship.
Yep.
If there is no number inside the absolute value, H is then 0. In the same way, if there's no number on the outside, K is 0. Okay. And if there's no number where the A is located,
1.
it's an unwritten 1. Okay. So as we look at any absolute value, let's write this one. Okay. We can tell what direction is this graph facing. Is it facing up or is it facing down? Which number tells us how it's facing? A, H, or K? Which value tells us what direction?
A.
It's A. A tells us where it's facing, and we have two options. Is it positive or is it negative?
This one's positive.
So if it's positive, it faces
Up.
up. If it's negative, so up cup, it can hold water. If it's negative, it
Down.
faces down. So in this case, this faces what direction?
Up.
Up. Okay. What is the slope?
2.
2. What did that do to our graph? Our parent function.
No.
What does 2 do?
Makes it would stretch it.
Stretches it and makes it skinnier. Okay. Right. Where is my vertex located? Vertex is a coordinate point. Where is the vertex located? We just wrote it.
5, right?
Which value is 5? K is 5, so it goes in which place? The X or Y?
Y.
Y. Okay. What is H?
Negative 3. Well,
X minus, well,
What does our standard equation say?
it's minus H.
Okay. X minus H. So the standard equation has it as a negative sign.
so it's a positive.
So
it's
K is
Positive.
Wait,
just that. So
H,
H is just
3.
3. So 3, 5 is our vertex. Is there shift in this graph from the origin? Has it been shifted from the origin? Yes or no?
I guess yes.
Yes. Okay. Because it moved
Up.
from 0, 0 to
3 to 5.
3, 5. All right. So I want you to draw this on your paper. Use your clear thing. And so what's the first thing that we're going to do? The first thing
It's going to be the slope, so.
is we need to address the slope. So we draw a single line with a slope of 2. Right? Okay. Then we reflect it across the y-axis to get our absolute value function. Okay. Now we're going to move it.
Up.
We're going to go up 5. And then where else are we going to move?
Over 3.
Over 3. Excellent. Okay. So if we were now looking at our graph, does that graph have any y or any x intercepts? Does it have any x-axis intercepts?
It doesn't.
No, it does not. Does it have any y-axis intercepts?
Yes.
Any y-axis? Y-axis intercepts?
Yes.
Yes. How many?
1.
Just one. All right. And so we would be able to find the intercept by plugging in when x equals 0. Okay. So what would that be? What would be the intercept? Remember, we have one y-axis. We're answering the question when x equals 0, y equals what? So we can graphically find it, or we can algebraically find it. What is your assumption based upon your graph? What do you think it might be? Make sure you're still at 2.
11.
Yeah, it was just kind of.
There you go. So
I got 11.
you got 11. Okay. Let's see. If x equals 0, let's plug in 0. So what does our equation become? 2 absolute value of 0 minus 3. It's negative 3 plus 5. What happens to this negative 3 when it comes out of the absolute value?
Be positive.
Positive. So it's really 2 times 3 plus 5, which is
6 plus 5,
5.
which
is
is 11.
11. Excellent. Okay, so your
Wait, how did you get to? Wait, when you turn it to positive 3,
Mhm.
it became
2, because this is always times. There's always a
Yeah.
So
multiplication.
2 times 3.
Uh-huh.
Okay. So okay. I was adding. I got confused. I was like,
Yeah, we always say it's always a multiplication
okay. So
when it's
2
on the
times
outside.
3 is 6 plus 5. Cool.
So you said from the graph it looked like it was at 11. Algebraically, we solved it. It's at 11.
Mm-hmm.
All right? Great. So last week I handed out these function. Do you have those function papers? Okay. These need to go in your interactive notebook. So make sure they get glued inside your interactive notebook. It should look like this. Okay, I gave you 2. There's another one too.
Is it-
If I didn't give it to you, I apologize. They are posted on
Wait,
our
what is
Google
this?
Classroom.
Yeah. I
So you
saw
have
them
2 different
online.
ones. I also gave you this one, our function family one.
I have
That's
that.
going to be homework. Okay.
I just,
So I apologize. I
Yeah,
didn't
definitely.
print these out. This one right here is our generic form of the functions that we just learned today.
okay.
So we want to have it in there, and it all describes your H and K
Oh.
and how to move around. So this is a visual. Print this one off of our Google Classroom handouts. I did pass out this one. That's your function family, and it should be filled in. I believe I passed out the answered one.
This one? Oh, yeah, the answer one.
Okay.
I did.
So make sure that it
Yes.
also goes into your, yep, so cut it out, make sure it also goes into your interactive notebook. And it will describe, this will be a way that we will answer some homework questions this week, where we will use words. If you will look at number 3 underneath the translations of it, see where it has f of x equals absolute value of x plus 2.
Mhm.
And then it says shifted left 2. So that is verbally, we are writing down what that graph has
Does.
done.
Okay.
Right? So now we are going to get to stand up and we're going to be a graph. Okay, so I want you to stand out of your chairs and find the origin of the coordinate plane that is at your seat. We each have your own coordinate plane. We are going to be the graph. Our arms are going to define our slope. Okay, so 45-degree angle is our regular parent slope. If we've had shift, you know, where we compress, we're going to pull up whenever we're stretching. We're going to go down when we've got compression. Okay, and then positive y is going to be towards the board, towards me. Negative y is towards the wall. If you were looking down, it's like we were looking at our regular plane. So on your left is going to be negative x values. On the right is going to be positive x values. Okay? So we are going to describe this transformation. I want you to move on your coordinate plane where this graph has gone. So we have f of x equals the absolute value of x minus 7. So slope-wise, what does this graph look like?
It's our parent function.
Parent function, 45-degree angle. Okay, now what does the graph do?
The y-intercept would be -7.
Okay, so if you were the graph, you would go where?
Down.
Well, I can't go 7.
Okay, you would go backwards. Perfect. Okay, excellent. All right, come back to the origin. Let's look at this guy. F of x equals 1/5 x. 1/5 absolute value of x.
So we would count that.
Awesome.
Yeah, so you're
That's a great 1/5 slope with your arms.
fat one.
Okay. So have you moved anywhere?
No.
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 Still
Okay.
origin.
We just have a fat graph there. Okay. Let's look at this one. F of x equals negative absolute value of x. So we're going to start with our,
Wait, would you just turn around? Or-
yeah, you can turn around.
So like that.
Excellent. I love that. You got it before I even mentioned it.
Yeah.
Okay, so we're just going to turn around for that one. Okay, let's go back to here. F of x equals absolute value of x plus 6. So where do we start? We always start with our slope. Our slope is
Just be parent function?
parent function.
So right here.
Okay, and now where do you go?
Up 6. Wait,
negative because it's the inverse.
Okay, so we have
Oh,
one
yeah.
that says up. We have one that says down. Is this attached? Is this an H value or a K value?
I guess at H, right?
It's an H, so should we
It's
move up and down
inverse.
at all?
Oh.
I guess not.
Where does H move us?
On the x-axis?
On the x-axis.
And so we go over 6.
Okay, which direction do we go?
But you said it was inverse though, right? So,
So
it's
it would be
negative
negative.
6.
Awesome. Okay,
Right.
so you should be standing on your coordinate plane. We should have moved to the left by 6. Perfect. Okay, let's go back to the origin. We're going to do 7. Show me 7. What does 7 look like?
It used to be that, right?
Yes. Perfect. Okay. Did you change from the origin?
No.
What kind of change did we have in the graph?
We didn't, I mean, it,
We had
it just stretched it.
we had vertical stretch. Okay, it got skinnier. Excellent. Okay, number 8. All right. I'm gonna give you guys a minute to do this one on your own. F of x equals absolute value of x minus 4 plus 6. So we always start with slope. Slope looks like perfect. Now where do we move?
Yes.
Over 4.
Okay.
Wouldn't it be opposites?
But it's on the x-axis though, right?
Okay. Which ones? Okay. Perfect, Josiah. Okay. So we have moved
Well, over
positive 4
4, up 6.
to, so our H value, we have H and K.
Yep.
Going positive 4 up
6.
6. Our vertex is located at
4, 6.
So what's our
4.
slope?
The slope?
It'd
Oh,
just
what
be
is the
parent
slope?
function. Just parent.
So it's x.
No,
Well, oh, I
Or
guess
it's 1. Yeah. It's parent function.
parent function.
Yeah. So you go over 4 and up 6.
Excellent. Perfect. Okay. So now do number 9. F of x equals negative x plus 9. Where are we going to move?
That is so. Wait.
X plus 9 moves where on the graph? Where are you going to move?
Oh, that's
Wouldn't it just be you go over? Since it's negative, you turn around, and then you go over 9 on the x-axis. Negative 9 on the x-axis.
Okay, negative 9 on the x-axis is
So,
which
you're-
direction?
The right. Oh wait, no, it's the left.
There you go.
So
Okay.
it'd be over here.
So we're going, yep, negative 9, and we're turning around.
Okay.
Yep.
Okay, opposite. Well done. Okay, let's look at this one. F of x equals 4, absolute value of x minus 1.
So slope's gonna be that,
So we're skinny,
and then we're gonna move over 1 on the x-axis.
positive or negative?
positive.
Positive 1 on the x-axis. Okay? Oh, here we go. F of x equals 2, absolute value of x plus 5 minus 4. So our slope is
2.
2.
Yeah.
Okay? Now where have we moved? What do we move on the x-axis?
Wouldn't it be negative 5?
Negative
So we go
5 on the x-axis. And where do we move now from the y-axis?
Down 4.
4.
Down 4. So we should be in quadrant 3.
Yep.
Okay, fantastic. Right? Let's look at this one. Our last one here, looking at it algebraically. Negative 5/3 absolute value of x plus 2. Negative 5/3, is this greater than 1
Yes.
or less than 1?
Greater.
That's greater.
Greater than 1. So it's actually still been stretched.
Mhm.
But then it does what?
Just
He turns around
yeah.
because he's actually an upside down 1.
Yeah.
And then you go. Then you go.
Over 2, so we
Wouldn't it be?
Do we go left
It'd
and
be-
right at all?
It'd be No.
We go.
You go up. You go.
Okay,
Yeah.
back yourselves up. Awesome. Well done. Okay, so now we're going to look at it in words. So we've seen it visually. So we're just going to step where it says translated 9 units to the right. 9 units to the right would be,
This direction.
okay,
Mhm.
and that means that's an H value. So this would be X minus 9,
Yes.
correct? 9 units to the right. Okay?
Wait, wouldn't it be plus?
Well, since it
Oh, because it's the inverse.
Yeah.
X-axis is always the opposite because we've got to get this on the other side. So X equals 9
Yeah.
means it comes out to X minus 9 when we put them together. Okay? So reflected in the X-axis.
We would just turn around.
Excellent. Well done. Okay. Vertically compressed by a factor of 3/4. That does what to us?
Makes us get compressed. Yeah.
Yeah.
Fatter.
Okay. Yep. Fatter. Okay. Shifted 4 units up. Okay. Well done. Everyone stepped upwards. Okay. Reflected in the x-axis. So reflected in the x-axis, then translated 2 units left of your original left.
Right. I was about to say.
Okay. Fantastic. Okay, and so when we translate 2 units left, that looks like left and right is always our x-axis. 2 units left means we're actually going positive. Okay. Vertically stretched by a factor of 5.
So
Real skinny. Okay. Then translated 3 units right. Well done. 3 units right looks like what?
X minus 3.
X minus 3. Okay. Translated 7 units down and 4 units left. So 7 units down is which one? H or K?
K.
K. So
Yep.
7 units down, which value would go here?
That would be
Seven.
7.
-7,
Yes.
because it's strict. 4 units left.
It's H, so it'd be positive 4.
Okay.
Because it's the
Yeah,
inverse.
it would be like this, x plus 4,
And then negative 4. Yep.
and we would have that, okay, for our vertex, okay? Vertically compressed by a factor of 1/2, okay, then reflected in the x-axis. Perfect, right? 21. Vertically stretched by a factor of 4. Good, I see arms up. Then shifted 2 units right, okay, and 1 unit down. 2 units right, 1 unit down. Perfect. So that makes our vertex what?
Negative 2.
2,
And then -1.
-1. Okay, if we were to write this, this would be x minus 2 though,
And then, yeah,
and then a
-1.
-1, right? Okay. Reflected in the x-axis, then translated 8 units left, perfect, and 5 units up. Okay. Wow, well done. Okay, so now we have a vertex of -8
And then 5.
and 5, which would be written x
Plus 8
plus 8
plus 5.
plus 5. Well done. Okay, you may take a seat. You guys make excellent graphs. Well done. Okay, so now what I want you to do on your coordinate plane is I want you to draw this one independently.
Do you want us to use this?
It doesn't matter. You can use that if you'd like, or you can just draw it directly. Okay. Where would we draw this? So I want you to identify the A value. I want you to identify the vertex. What is your vertex? Write it as a coordinate. If you're more comfortable doing it with your clear one and then shifting it, you can do that.
So draw it as a point? Or draw
I want you to draw the graph onto your Draw your whole graph. What would it look like? So if you are quick sketching and you see this on the ACT, y equals absolute value of x minus 2 plus 5, and they ask you to match a graph, you would be able to quick sketch your graph and then find the one that matches you, correct?
Yes.
Perfect.
Okay,
Good.
so
I was about to say.
it slides over and then goes. Is it? Are you saying so would 2 be the slope? If it's
I don't know. What is our slope? Where is a set? Where's your parent function that we wrote down?
Since
Did you
A would
miss
sit.
that?
yeah. It's,
Today? Where is our parent one?
Are you looking for A? A can be called slope.
Yep, remember, so we need to have our. Okay, so there's our standard equation. So what is our A value?
Oh, so the slope is 1.
Perfect.
Okay.
Excellent.
Okay. And then you go over 2.
Uh-huh.
So it's going up by 2, right?
Well, so first we need to find our vertex. Right? What did I say our vertex was when it was in this form?
It'd be the inverse, right?
So our vertex is HK. Our value's already given to us. What is our H
so
value?
Negative 2, 5.
What is our H value?
2. 2. 2, 5.
2, 5. So we find our point 2, 5. 1, 2, 1, 2, 3, 4, 5. There's our vertex. So from this point, I am drawing a line that has a slope of
1.
1. Okay, and then he gets reflected. Okay. Was there shift?
Yes.
Yes. Okay. What is my axis of symmetry?
The X axis.
X-axis?
Or-
Let's draw a line. Draw a line straight down the
Oh, no,
center of
be
your
a Y
graph.
axis, yeah.
Draw a line straight down the middle of your graph. Okay. What is the equation of that line that you just drew?
Y equals 0. Or X equals 0.
Oh, I thought this guy was x equals 0. If y equals 3, x equals 0, that would fall right here. What's the equation of this line?
Y, X equals 2.
X equals 2.
Okay.
X equals 2. Do we see that in our vertex anywhere?
Yes.
X equals
Two.
x equals 2.
Okay.
Our axis of symmetry will always be the h value of our vertex. Okay, so if I say my vertex is at 4, 6, my axis of symmetry is
4.
x equals
4.
4. I have negative 12, 3. My axis of symmetry is
X equals negative.
x equals negative 12.
Okay.
Okay? Because it is that vertical line that goes through.
Can I grab that eraser? Thank you.
Since I took yours.
No, it's
Okay, so graph this one. 1/4 absolute value of x plus 2. So you can write your A value down if that's helpful. Write the coordinate for your vertex to know where to start. If you've drawn it on your clear sheet, you can draw your slope first and then shift it. Perfect, Josiah. Excellent. So your A value, write your A value, and then label your vertex as a coordinate. Perfect, Jonathan. Perfect. Okay, so what is the coordinate of your vertex?
It'd be 0, 2.
Perfect. What is the equation of your axis of symmetry?
X equals 0.
X equals 0. Okay, A value is
1/4.
1/4. What type of dilation did we have?
Compress.
Compression. Fantastic. And for our big picture learning, these H and K's, our A's, H and K's, will identically move every single graph we learn for the rest of the year.
Okay.
Okay? So this is why we are spending time on this, because now you will be able to look at any equation and know exactly how the graph moves. Okay, so let's look at this. Now that we have been able to look at an equation and write a graph, well, can we do it the opposite?
Yep.
Okay, so here is our graph. What would the equation be? We simply need to plug in A, H, and K. Right? So A value,
Looks like it's just 1.
1, so X.
okay, because if I go from 0, 2 to, or yeah, 0, 2 to 2, 0, my A value is 1. My vertex is where?
0, 2.
0, 2. My vertex, or 0, negative 2. My vertex gives me which values?
Your
Your
So
H
your
and
H and-
K.
H and K. So I get to do this. Okay, so was there shift?
No.
Yes.
Yes.
Well, down 2, yeah.
Yes, down. Okay, so now all we need to do is take the values that we just found from our graph and plug them into our equation. So how would we write the equation for this graph?
So it would be
Y
f of x
equals
equals
X.
1 or A, whichever.
Or, yeah.
And then absolute value of x minus, well, just, yeah, 0. And minus 2.
Well done. Do we need to leave that?
No.
No. Do we need to leave this guy?
No, he can be just
Okay, so we simplify it to f of x equals
A absolute
Absolute value of X
X.
minus 2.
absolute value of x minus 2.
That's right, we don't even need the A.
Perfect. Perfect. Well done. So, now can we do it from a word problem?
Probably.
Probably,
I know.
right? Yes. Okay, so you're sitting in a boat on a lake. Lovely. Can you picture it? Yes.
Or
You can get a sunburn from sunlight that hits you directly and from sunlight that reflects off the water. What do we know about reflection?
It's
We learned in physical science that the angle of reflection is identical. So that looks like what?
well, it's gonna be kind of fuzzy.
An absolute value equation, right? Okay, sunlight reflects off the water at the point 2, 0. So what would be this point? What would we
X
call
minus
it?
0.
HK.
Okay.
Vertex.
Vertex. Because if it's reflecting, it's the point where it changes direction.
Yeah.
So here's our vertex. And it hits you at another point, 3.53. Okay, so our vertex here is at 2, 0. So we're able to quick sketch. I want you to sketch those 2 points on your coordinate plane. So since we have the first one, we have our vertex. At 2, 0, we have our next point at 3.53. We have the right side, correct? So how do we draw where it's coming from? It's going to reflect over our axis of symmetry. And so it came down that direction, right? What is our axis of symmetry?
It'd be X equals 3.5.
Perfect. X equals 3.5 is our axis of symmetry. So here's our graph. It's coming in, it's hitting the water at to 0. It's bouncing up. It's now hitting me there. Okay. What is my A value?
It is.
How would we find our A value?
Right, so 3 over 1.5.
Okay.
So just
Slow. Yeah.
2
So
over 1. I think.
rise over run. You counted it on your graph. We also learned that it's our difference of our y values. So 3 minus 0 over 3.5 minus 2, which is 3 over 1.5. We got exactly the same as you counted on your graph. 3 divided by 1.5,
It's just gonna get
2.
2. So our A value is 2. Our HK value is what? What did our definition say? HK is always going to be our, it's on your vocab,
K is Y. H
Mhm.
is X.
okay?
So
We also had a
H is-
vocabulary word that said it is always our HK value. What was our vocabulary we wrote down a little bit earlier? It said this value is always our HK. It's a special point.
Input? Well,
It's a special point on the graph.
The birth.
The vertex. Does it give us our vertex?
Yes.
What was the vertex?
2, 0.
2, 0. So 2, 0 is our HK value.
Okay.
Okay. The vertex is always our HK value. So now, can we write the equation?
Yes.
Yeah.
Okay. So what would be our equation? What's the A value? What's the first part,
2.
Josiah? Okay, 2. Okay. Jonathan, what's our H value?
It 2, right?
2.
Wouldn't it be, yeah, -2?
Okay, because it's always minus.
Yeah.
It's always minus. We put that. And then our K value is
Just
0.
0.
So
Do we need to
nothing.
write it?
Nope.
Nope. So here is the path of the sunlight to absolute value x minus 2. Okay. So now we've been able to write it all and figure it out with a word problem, by graphing according to an equation, and by looking at the graph and then writing the equation, right? So we figured those out. We had our graph, it looked just like that. Okay, so let's look at this. What is our domain? Let's revisit. What would be the domain of our graph? Or our sunlight one? What is the domain?
So
Domain is which part of the graph?
the rise.
Horizon.
The run,
No,
the
it's
X,
the
the
run.
X-axis.
Domain
that's
are
right.
all of the x's.
So
It's the run.
So domain is what?
um
All the x's that this graph takes up.
I mean
It goes
4.
into infinity.
Negative, well, yeah, okay. So just infinite X, like.
What is that called?
All real value.
All
real X
reals.
values.
Okay? What is the range?
All reals, right?
What is the range? So domain are our x values.
So the rise.
Range is the y values. So what y values does this graph take up?
All positive. All
Okay.
real, all
So we
positive.
write it. Y such that y is what?
All real positive numbers.
Greater than,
Or
equal to 0. Right? All positive y values. Y such that y is greater than or equal to 0. Right? All done. Okay? So now, were we able to graph an absolute value function?
Yes.
Yes. Are we able to stretch and compress it with A?
Yep.
Okay. Can we predict how it moves according to H and K?
Mm-hmm.
Okay. H moves it how?
H moves down the X-axis.
On the x-axis, in the same direction as the number or the opposite direction?
Oh. Opposite.
Opposite direction. K moves it where?
Up
Up
and
and
down.
down.
Up and down on the y-axis. Same direction or opposite?
Same.
Same. Okay. And can we name the domain and the range for each of our functions?
Yes.
Yes. Okay. We hit all of our values. So with that, for your homework, you have this absolute value functions worksheet. It will give you the function, and then there are things that you can fill in, and I want you to add this column that says axis of symmetry onto it. It's written in the instruction notes
Okay.
as well. But you will write the vertex. Vertex is written as a coordinate. That means it will be a coordinate point for your vertex every single time. The transformation, I want you to verbally write what it does. So if it shifts left by 2, or if it flips over the axis, we are writing it in our verbal terms in that
Okay.
one that we practiced where it had it verbally written. Also in your interactive notebook where it has it verbally written, that's how we want to describe the transformations.
Okay.
Then I would like you to write the axis of symmetry. It will be written as the equation of a line. It will always be an x equals and then a number for your axis of symmetry. So this one is to be completed. The second one that is to be completed is this absolute value graph and transformations. There are 2 pages to it. The second page has 3 columns of little guys to cut out, but that's just for saving paper in a class. So just use one column. All 3 columns are exactly the same.
Okay.
So you will cut it out and you will find the graph, the equation that matches the graph, and then you will glue it into the top spot underneath it, okay? Then in the 2 bottom boxes, in the first box, you will write the coordinate of the vertex. In the second box, you will write the axis of symmetry, okay? And that is labeled. So these are the 2 assignments for our absolute value equations, okay? So I have chapter 2 review slides. We are not going to address these in class because we don't have time today to hit these. Now, you guys have access to the slides.
Okay.
They are posted on the Google Classroom. So I encourage you to go through this because you also have your chapter 2 test to take this week. All right? So, for the test, you need to be able to answer these questions. If you can answer these questions, then you will do well on the test. You will need to know your vocabulary for the test. I also have the vocabulary listed under the vocabulary to know on the
Okay.
Google Classroom, so you can review over that as well. Okay, so here's our big picture. So I encourage you, here's also the list of vocabulary. You need to know these things directly. So again, go over these slides, pull them up, and review these. It's under week 6, 2.8, and review for that. So this will kind of walk you through all of our chapter 2 review items to do it. And then for your test is broken up into 2 different pieces. I have removed a big portion of the written portion of the test, and we've added a practical one on Desmos. There's a link on there. So the first part of your test will be a practical art activity. Let me pull up to show you what it looks like.
I think I saw the email last night that notified me about it.
So it has the example of my graph. You will be drawing a picture, whatever it looks like. There's lots of examples on the instructions. You will be drawing a picture using lines only. Okay? So we've learned how to write the equation of a line. We've learned how to bound it with a piecewise function and put specifics on it. And we also learned how to do the inequalities of it. So greater than or less than. So there are some specifics. You must have at least 15 lines. You must have something that has an inequality that is shaded portion of it. Okay? You must have at least one coordinate point written in the coordinate point of it. So I think those are the ones that I have on there. I've got the list in the instructions for it. This is the example that pulls up. Again, so we are going to bound the lines, and you can see when we're on Desmos, we write our line and then we bound it within our brackets and tell us which part of the line we actually want to use. What's great about this is if you put a line up there and you need to move it, you can just, now you know which one to move. So our values on the outside, move our lines up and down. Our values connected to X inside, oh, it has to have at least one absolute value. We'll shift it along the X and Y axis. So this is the first part of your test. The second part is just a 2-page written portion of it. So those can be done together separately, however you would like it.
And how many of these are there for the first part? Is it just one?
So this is, you will draw one picture.
Okay, just making sure.
Yeah. So the instructions are all written on there. When you open it up, there are even more instructions within the PDF that is attached onto there. Everyone already has a Desmos account. So once you have you complete it, in the top, it says you can, let's see, you will be able to go over here and click share graph. And so you will copy this link and you will submit that link
Okay.
on your Google Classroom. So you'll just put that in there and submit it, and then I'll be able to pull up your graph and be able to see it. So you'll just share with that, all right? Any other instructions? Okay, so don't forget, you can take your coordinate plane. These are yours to have now. So as you are doing your homework, if you find that it is beneficial for you to put it on there and then move it around, that is yours to have. Okay, and I need all of your homework if you.
I think I already got mine to you, right?
Yep.
Yeah.
Okay, and your bell reader. Perfect. All right, well done.
Thank you.
You're welcome. Full day.
Yep.
Yep.